Hi everyone. So last week I explained to you about variables, local variables in particular, which are the ones that are defined within the blocks of code, like within what happens when you touch the object or when you start the object. So local variables are variables that are declared inside those blocks of code. So today I'm going to talk to you about global state or state that is global to the objects and that persists independent of the events that happen to the object. So for example, here's an example of this yellow object where I'm going to click the object and it says I've been touched one time, and then I click it again and it says two times, and I click it again, 3 times, 4 times, 5 times, etc. So this persists through independent of just the particular event that I am handling on those blocks of code, right? So let me show you how to do this kind of state that persists. So let me show you this script. Um, So before the first thing that you saw in this script was this default keyword with all the the different blocks of code for the different events. So when we want to have a state that persists, that stays in the object, associated with the object, we declare the variables up here in the beginning of the file. So in this case, I'm declaring an integer variable called counter, initialized to 0, and then what I do here, every time that the object is touched, I increment the counter. Counter equals counter plus 1, and then I print out the string I've been touched counter times. So what that means is that when I touch it once, the counter was 0, then the counter becomes 1. But that stays. Okay, so that 1 stays there. So when I touch it again, I click it again, then the counter now is 1 and increments to 2. Okay, so it persists. It's declared up here, and it means that it's global to the object, and it persists for as long as the script is running until we either add it and save it, or we reset it again. So even right now I didn't save anything, so if I click it again, it still remembers the number that it had. Right? It's 20 times, 21 times. It's only when I reset it that then it returns back to 0. 1 time, 2 times, 3 times, etc. Okay, so this is global variables that stay associated with the object for as long as the script runs, and it persists. It remembers what, the script remembers what were the values. Let me show you another variation of this, which is this second object, which is a counter but it only counts up to a certain number and then goes back to 0 again. So let me show you. 1 time, 2 time, I don't remember what the limit is. Oh, I guess it's 12 times. So it reaches 12 times and it goes back to 0. So let's see how this is done. All right, so I have, again, the counter, which is a global variable over here that I initialize to 0, and then I'm saying that the limit, and just to differentiate that this is a variable, but I'm using it as a constant. I never change it. So I have all capitals, sort of as a convention. When you have a variable that never changes, it's actually a constant. So you write it with all capital letters. So the limit is 12, and then what I do here, I increment the counter, and I say that same message. But then what I do here now is I'm testing if the counter, the remainder limit equals 0. So basically, when it reaches 12, when the counter reaches 12, this is 0. And in that case, then I say I reached the limit and I set the counter to 0 again. Right? So it's a conditional over here that I test if the counter, the remainder of the division of counter by limit is 0. In that case, it means that I reached 12, and then I reset the counter again. Okay, so that's a possibility. There are other ways of doing this, but it's a way of having logic associated with the state variables, the global state variables that we keep remembering, and we can change it over time by whatever logic we need to change. Okay, so here's another one. So this one is going to give us the Fibonacci numbers, if you remember from the Fibonacci algorithm. So if I click it, it gives me 1, 2, 3, 5, 8, 13, 21, 34, etc. And even if I go back in here and click another object, go back to the Fibonacci, it continues from where it left off. Okay, so every time, so it remembers what were the last numbers. And if you remember about the Fibonacci series, in order to get to the next number, you need to remember the previous two numbers. That's how you generate the Fibonacci series. So if I'm going to show you how this is done. So what I need to remember are the two last numbers, right? So I just have to remember what were the two last numbers. And I started in the beginning, it's, as you remember, 0 and 1. Those are the first two numbers of this Fibonacci series, right? So 0 and 1, and then every time that I touch it, I compute the next number, which is n1 plus n2, and I print it out, and then I update. So n1 becomes n2, so the n1 becomes n2, and n2 becomes the next number, right? So I switch them up. So now the n1 and n2 have the correct numbers that will be needed to generate the next number when I come and touch it again. All right. So in this case, it's a case where it's a global variable. You need two global variables, not just one, and you need to update them every time that you touch the script. Okay, so here's another one that this has not to do with numbers, but it has to do with colors. So every time that I touch this object, it's going to switch color. I think it's 4 colors or 5 colors, I don't remember. White, black, red, green, and blue. So it's 5 colors. So let me show you how this is done. All right, so now I have many global variables over here, and they are so I already told you about data types in here. I told you about integer types, so that the integer numbers. I told you about the strings, which is a text, and there's a new data type here, which is a vector. A vector is just a set of 3 numbers that is meant to denote typically coordinates of the world, but it also meant to denote the colors. If you remember the lecture that I gave about the way to represent colors in the RGB, the red, green, and blue intensities of red, green, and blue, this is exactly what is going on in here. So the colors in this language are represented by a vector of basically 3 numbers, 3 real numbers. And each of these numbers is between 0 and 1. So it's an intensity, it's basically an intensity of red, green, and blue that is a decimal number between 0 and 1. The white color is when they're all 1. So the white color is 1, 1, 1, 1. The black color is when they're all 0, 0, 0, 0, 0, 0, 0, 0. The red is when the first component is the red. So this is 1, 0, 0 is red. The second component is the green. So 0, 1, 0 is green. The third component is the blue. So 0, 0, 1 is blue. And of course, you can have many numbers here. You can combine any number, that as long as it's between 0 and 1, you can get all the colors that are expressible in this system over here. So we have 5 colors, and these are their values over here. Could have other colors too. And then I have a counter over here that starts at 0, and I initialize this script with the color white. When recompile or when I reset, it becomes white. And then every time that it's touched, it computes the next number, and it makes sure that it's always between 0 and 5. Okay, so this is the remainder module is very useful all the time. So you increment the counter, but only up to when it reaches 5, it comes back to 0 again. Okay, so this is counter equals counter plus 1, remainder 5, meaning that this goes from 0, 1, 2, 3, 4, 0, 1, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and all is like that, okay? And then what's going on in here is a conditional, many alternatives that I also explained the conditionals last time. So if the counter is 0, then it's the white color. If the counter is 1, then it's the black color. If the counter is 2, then it's the red color. If the counter is 3, then it's the green color. And if the counter is 4, then it's the blue color. All right? And this is done with this function of the virtual world that's called LL set color, that takes the color and which side. You could also say, only one of the faces would change the color, but in this case I'm changing all the faces of the shape. All right, so that's how you change colors and how you flip through 5 alternatives, and so that's you keep the global state in the form of that counter over there. All right, so global state is super important here. It's state that is associated with each of the objects, and it persists beyond the particular event that happened to it. So the next time that another event happens, the state is still there, updated to the latest value that has been updated to. Okay, so this is different from the other local state. If you remember over here, let's see that we have, for example, I'm not there. I need to move over there. So this one, for example, that has, for example, this local state name, right? This local variable name is something that exists just here while this touch event is being handled. But then once the touch event is done, once we are done with this block of code, that variable is released, like it doesn't exist anymore. Nothing is remembered. So next time that we touch this, there will be a new variable name that is allocated in memory that gets this value, and then it just goes away again. Nothing is remembered. Okay, so these are local variables as opposed to the global variables over there. Okay, these ones that are kept here outside of any particular block of event handling over here. Right, so these persist and the other ones don't persist. Okay, so I'll see you in the next video.